Rational functions. If I say rational function, what does that mean? Yes, fractional functions. So stuff like f of x. This was a shorter unit, so we can just cover it fairly quickly. Is equal to x squared minus 1 over plus 2. Okay. We're just going to do a couple of graphs because that incorporates everything. So we're going to graph this. I need verticals, horizontals, x, y's, PODs. Okay. Literally on the test, in the multiple choice section, I'll give you a function and I'll say, what are the vertical asymptotes? What's the POD? What's the blah, blah, blah? In the short answer, basically, I give you a function and I say graph it. Okay, so I can cover everything we need to cover with 2 graphs. All right, so what do we do? If I say graph this, what do you need to do first? In fact, did you say find everything out? Okay, yes. Factor would be a good place to start. So the top turns into x plus 1, x minus 1 over x plus 2, x plus 1. Okay, so what happens now? What? Sorry, Naya, what happens now? What am I canceling? Ooh. I should use pink. Boom, boom. All right. So we're left with x minus 1 over x plus 2. Okay. What you canceled is what? POD. What does POD stand for? Perfect. So point of discontinuity at x is equal to -1. It's what makes that bracket 0. How do you find the y value of the POD? You put it into what's left over, right? So the y value is going to be -1 minus 1 over -1 plus 2, which is -2 over 1, which is -2. So the coordinates of your POD are -1 and -2. You got a mark. Good job, peoples. Is that a 5? Okay, what next? All right, vertical asymptotes. Vertical asymptotes are after you cancel. All right? So if you just say vertical asymptotes are what make the denominator 0, you would say -1 is a vertical asymptote. But we know -1 is... What was that? Is not, because it cancels and it's POD. So cancel and find your PODs first and then do the verticals. Okay, the verticals are what's left over and make it 0. In this case, that is -2. All right, we got our vertical, we got our POD. What else do you want to do? Horizontal? How do you figure out the horizontals? So those are the 3 rules that we learned, right? The three rules were if the degrees are the same, and it doesn't matter if you look at the factored form or the original form. If the degrees are the same, you look at what? Leading coefficients. 1 over 1 is 1, or degrees are the same, 1 over 1 is 1. Doesn't matter which one you use. So this has a horizontal asymptote of y is equal to 1. Just as a side note, if they are not the same, what if you have that? X plus 1 over x squared minus 3. The bottom is a higher degree than the numerator. Asymptote is y is equal to 0. Okay? Yeah? Yeah. Well, it doesn't matter if you do it after or before. And if you have the top is a higher degree than the bottom, you have no horizontal asymptote. That should be y is equal to 0 is the HA, and this has no HA. And for those of you taking calculus, you'll learn how to find the slant asymptote. I know you're all excited. Okay, side note, we're back onto normal note, straight note, side. What's the opposite of side? Middle? Okay, middle note. There you go. Back to the whatever, the question. So we got our horizontal asymptote. What else do we need? These are next year's grade 9. You hear that? She thinks this is art class. Oh. Beautiful. See, she's saying this is beautiful. They were like, I don't know, maybe art? That looks very artistic. Okay. What else do we need? XY intercepts. X-intercept is when? So does it matter which function you put it into? I.e. the factored or the unfactored? It doesn't matter. I would just put it into the unfactored. But really, when you're doing it, what's the only thing you have to look at? You put x is equal to... Let's do the y-intercept first. Y-intercept is when x is equal to 0. So if you're doing that, what's the only thing you look at? The constant terms, right? Because if x is 0, everything else goes away. -1/2. Put 0 in here, -1/2. Doesn't matter which one you use. So for the y-intercept, we get y is equal to -1/2. So it has coordinates 0 and -1/2. Okay, the x-intercept is when y is 0. It makes your life easier if you use the simplified or factored form. So I'm going to use this one. So I go 0 is equal to x minus 1 over x plus 2. So the only thing it's going to be, if you multiply the x plus 2 up, it goes away, right? So you get 0 is equal to x minus 1, so x is equal to 1. So the x-intercept is 1 and 0. And if you remember when we were doing equation from the graph, when you had your x-intercepts, those became the factors in the numerator, right? Remember that? We'll do an example because I know you're excited. Okay. We'll do an example of it. Okay. Do we have everything we need to graph it? We do. All right. Vertical's at -2. Horizontal is at 1. X-intercept is 1, 0. Y-intercept is 0 and -1/2. Where's my POD? POD is at -1, -2. -1, -2 is a POD. Remember this? Swoopy doop? Swoopy whoop whoop? What do we call it? You have to go through those points. You can't touch verticals and horizontals. I will not give you one that crosses the horizontal. Maybe. No, it doesn't. It doesn't. It doesn't cross the horizontal. I won't give you one that crosses the horizontal. All right? So that's there. 99% of the time, it would be diagonal, but we're going to check it just for practice. How do you check to see where the other part of the graph is, like on this side? You pick any point, any x value that is to the left of your vertical. So -3. Put it into the simplified one. It doesn't matter, but you might as well put it into the simplified one, x minus 1 over x plus 2. So check x is equal to -3. So y is equal to -3 minus 1 over negative 3 plus 2 is negative 4 over negative 1, which is 4. What do I care about with that number? You just really care, if you're at negative 3, is it above or below the horizontal, right? That's all you really care about. In this case, it's above, which confirms our that's the graph. The whole unit. That's pretty much the whole unit. I mean, we did equations from graphs. Do you want me to do one of those? Yeah. All right. Maybe. Perchance. All right. First of all, is there any questions about that? That's your short answer type question, right? Like, can you do that? What? Okay. Let's just do a graph to an equation. Oh, I can't draw. I'm just going to move this point.
Just going to move the point? What?
There you go.
Oh, okay. Okay.
Just so it matches.
I thought you could be like, make this that was 4.
There you go. Find the equation of this graph. Well, you don't have to. Nobody's putting a gun to your head. There will be. I guess there is a. There's no marks given, so you would lose marks that way. So there is a punishment. I guess. I don't know. Is that a punishment?
Yeah.
Is it?
Failing is a punishment.
I don't think you'd fail because of it.
No.
You just won't score as high as you would like.
How much is the thing worth?
20 or 100.
So if I just don't do it,
yeah. All right. Boom. F of x equals. Okay, what do we do? What should you do right away? What's the easy thing to pick out? POD is at negative 5. So what does that mean? Yeah, so that means you have an x plus 5 in the numerator and an x plus 5 in the denominator. All right, what else? Asymptotes. Vertical asymptote at negative 2. Sorry? Leading, what? Vertical asymptote at negative 2. That means you have an x plus 2 in the denominator, right? What else? Sorry? Are we done? Is that it? What are we missing? Why does it not make sense right now if we left it like that? What's the horizontal asymptote of this graph if we just left it as is, of the function that I wrote here? It'd be 0, right? Because the denominator has a degree of 2 and the numerator has a degree of 1. And it's not 0, it's negative 2. So what do I need? Yeah, how do I get another x? Just put an x there? Just randomly throw one up there? No. Anybody? Anybody? Sorry? What is that number? What does it represent? The x-intercept. Where does the x-intercept go? Into the numerator. Remember? Up here, when we were doing our go away. We're doing our x-intercept here. I put y is equal to 0 into this, and it was this that determines the x-intercept, right? So if we're going backwards and I give you the x-intercept, that's what you write in the numerator. So we go, it's at 5, so we have to have an x minus 5 there. Now does it make sense? Why? Yes, they are the same degree, but it's all ones. And we have our horizontal at -2, so you just throw a -2 there, and then you're done. Okay? Well, you can. Let's check it. Those are going to go away. Not unless you did something wrong. So if we go -2, y-intercepts when x is -0, over 2, cancel, negative, negative, positive. So it's 5. Okay? All right? We're done.